Hello guys, am I audible to everyone? Am I audible to everyone? Hmm. I think I am audible. So I will start with the solutions of LeetCode Weekly Contest 482, which was held today at 8 a.m. So this is the first question of the contest. This is maximum score of a split. Okay, okay. So yeah. So in this question, you are given an integer array nums which has a length of n. Okay. So you can choose an index I such that I belongs to 0 to n minus 1. And then you can choose a split index I and let prefix sum be the sum of nums 0 to nums I, and let's suffix minimum of I be the minimum value among nums I plus 1 to nums n minus 1. So for a zero based indexing, they have told us these two terms. And for any split index I, the score of I is defined as prefix sum of I minus suffix minimum of I. And finally, we have to return an integer which denotes the maximum score over all the split indices. So, like in this case, what I can do is that um, I can add everything up to here and then I can subtract the suffix minimum from here. So, like 10 minus 1, 9 plus 3, 12, and minus minus 5, which is 12 plus 5, 17. So, that is the answer. So, I took the prefix sum up to here and the suffix minimum after this and finally got the output. So this is simply a brute force question. Lead code questions are generally brute force. You do not require much thinking in them. So you simply go to every index, you store the prefix sum till that index, and you store the suffix minimum after that index, and you subtract both and take the maximum again and again. Right. So let me open the whiteboard. Okay. So yeah, like in this case, like let us have this example itself. What do I have to do? Score of I equals to prefix of I minus suffix min of I plus 1 to n. Prefix sum 0 to I and minus suffix minimum of I plus 1 to n. So maximum score at any I is to be found. So just a brute force approach, I can go to every index and calculate the score at every index, right? Because that is said in the question that maximum score over all the split indices. So why not go to every split index and try it, right? And how am I going to calculate this prefix sum at every split index? So like I am at 0, so I am at index 0, prefix sum equals to a0, suffix min equals to minimum a1, a2, so on up to an minus 1, right? And how can I find the suffix min? So I want them in a such an order that I can access the minimum element all the times. So which data structure can I efficiently use for this? I just want to calculate the minimum element in a sequence, and then I want to do some pop operations, right? So the data structure that can be used is a multiset, because what are the properties of a multiset? It contains all the elements in a sorted order. So you will have all these elements in a sorted order. You can extract the dot begin element. You can calculate it as the suffix min, and then you can erase the index a of I after doing the operation, right? Because whenever I move to I equals to 1, now this is also removed from the suffix minimum, right? Because when I am at in1, index 1, I equals to 0, and I equals to 1. So prefix sum equals to a of 0 plus a of 1. And then suffix minimum will be what? That is equals to minimum of a1, a2, so on up to an minus 1. But the problem is this time a1 is also not available, because we have to have suffix minimum of I plus 1 to n. So from a2 to an minus 1. So from this multiset, initially these elements were there in the multiset. We will remove now a of 1 from this, right? A of 1 from this. How can I do that? So let us say this was stored in a multiset named as MST. Whenever I go to I equals to 1, I simply do MST dot erase a of uh, a of 1, right? A of 1 or a of I. MST dot erase a of I. But the problem with this is that since this is a multiset, if there are multiple occurrences of a of I, all those occurrences will be deleted. But I just want to delete a single uh, occurrence, right? So I will do mst dot erase mst dot find a of I. So mst dot find a of I will uh, make me reach to the first occurrence of AI in the multiset, right? And then it simply erases that single occurrence. So do you understand why I did not use a of why I did not use mst dot erase a of I, and instead I used this? So this is just because I want to delete only a single occurrence. So is that clear to all of you? If there is any problem, you can um, tell it to me. Okay. So let us move on to the implementation part right now. So first of all, I stored all the integers in the nums array in this multiset, and then I say that currently the sum is equals to 0, right? I say that currently the sum is equals to 0, because prefix sum is initialized with 0. We will keep on adding the elements as we iterate on the array, and then we will initialize. Since we have to get the maximum score, I will initialize answer with minus 1e18, so that whenever we take maximum, it is always updated. right? The answer is initialized with such a low value so that it will always be updated. So some of you might be thinking, why not zero? Why not zero? Because the score can be negative as well. For example, in this one, negative elements are there. The score came out to be negative. So what will happen? If I had answer equals to zero, then the max of 0 comma minus 2 will be what? It will be 0. So the final answer would have been 0. But I wanted negative answers as well. So I take the answer as minus infinity initially. Is that clear? And then I iterate over the nums. Now I simply um, add I to my sum, and then so this now basically this has the prefix sum up to index I, and I delete the ith index because it will not be included in the suffix minimum, right? Because I plus 1, I plus 2, so on up to n minus 1 is wanted, and no occurrence of a of I. Is that right? Solve solve three. So someone is saying that he has solved three questions, so it is very good. The fourth question was quite tricky today, so uh, you do not need to worry. I will explain everything. Uh, okay, so now I'm saying that if if mst dot size, why? Because if there is no element left in the mst, it means that I am at the last element. I am at the last element. So there is no suffix minimum, and as it is said in the question, I is less than n minus 1. I cannot have the last element as a split index, right? So at the last element, what will happen? The array will be empty. So the array will be empty, and I do not want to consider that. So I just take the cases when the multiset is not empty or when the multiset is having some size. So I have done this since I is less than n minus 1. Otherwise, what will happen? If the multiset is empty, the minimum of the multiset will be 0. And that could be a misleading case, right? So n minus 1. So that is why we take MST should not be empty. And finally, we take the max of answer, comma, sum minus star MST dot begin. Why star MST dot begin? This will give us the suffix minimum. This will give us the suffix minimum, and sum obviously stores the prefix sum. Prefix sum up to I. Is that clear? I hope that is very clear to all of you. And finally, I return the answer after taking it max over all the split indices. Right. Okay. So now let us move on to the next question. Mahesh Singh also says three questions solved. A very good thing because again the fourth question is really tricky today. Okay. Okay. So now let us move on to the next question. So first question is done. I hope you do not have any problem in this question. Now the second question says minimum cost to acquire required items. How will you acquire the required items in the minimum cost? So you are given five integers: cost one, cost two, cost both, need one, need two. An item of type 1 costs cost 1 and contributes 1 unit to the type 1 requirement only. Item of type 2 costs cost 2 and contributes 1 unit to the type 2 requirement only. Right? And item of type 3 costs cost both, but it contributes 1 unit both type 1 and type 2. So cost both will give me 2 units in total, one for type 1 and one for type 2. And I need at least need 1 units of type 1 and at least need 2 units of type 2. You have to simply return an integer which will have the minimum possible cost to achieve these requirements. So I just need what? I need I need I need greater than equals to need 1 type 1 elements and greater than equals to need 2 type 2 elements. So what will be the basic approach? What will be the basic approach? So one element of type 1 cost 1, one element of type 2 cost 2. So I can simply say that Why not purchase every type 1 item like this and every type 2 item like this? Is that is that clear? Right? I hope that is clear, because in this way, what do you get? In this way, you get need 1 items with a cost of 1. So type 1 requirement is fulfilled, and need 2 items with a cost 2. So type 2 requirement also fulfilled. Is that the first answer clear? I hope that is really clear to all of you. Okay. And then and then we will have what? Need 1 into cost 1 plus need 2 into cost 2. So what is the other way of purchasing the elements? Now that let us say that cost both cost both is also given. So what will cost both give us? Cost both gives one type 1 plus 2 type 2 plus 1 of type 2, right? So what can I actually do right here? And 1 type 1 plus 1 type 2 will cost me how much? 1 type 1 plus 1 type 2 will cost me how much? It will cost me, it will cost me cost 1 plus cost 2, right? It will cost me cost 1 plus cost 2 if I use the first approach. If I use the first approach. Is that correct? Is that correct? So cost both gives one type 1 and one type 2, one type 1 and one type 2. So this which costed me cost 1 plus cost 2 if I use the first approach, right? And and then what will happen? So basically, if cost both is less than cost 1 plus cost 2, I will purchase some elements with cost both. And how many elements do I need to purchase if you carefully think about this? So let us say, let us say I need three items, three type 1 items. So let us say need 1 equals to 3 and need 2 equals to 5. And now let us say cost 1 was 10, cost 2 was 5, and cost 3 was what? 12. Right. Now, if the cost both is greater, then I would never have to use cost. If the cost both, if the cost both was, let us say, 20, then it is greater than cost 1 plus cost 2. So it will not give me any advantage over the first approach. So no advantage over first approach when cost both is greater than cost 1 plus cost 2. Now let us say cost both equals to 12. Now we see that cost both is less than cost 1 plus cost 2. So I know that I have to purchase three elements of this type. I have to purchase five elements of this type. So why not I used I use cost both three times? Why not I use cost both three times? Why not do that? Why not do that? Right. So if I use cost both, I use cost both three times. I use cost both three times. What will happen? 36 cost for 3 type 1 and 3 type 2. Is that clear? Because one cost both will give me one type 1 and one type 2. So after using cost both 3 times, I will get 3 type 1 and 3 type 2. And what is left now? I need to purchase, I need to purchase what? I need to purchase 2 type 2 more, and I can purchase it with the help of this thing, right? I can purchase it with the help of this thing, with the help of this 5 cost. Now, what if, so you understood this, right? So cost, I can, so this was the initial answer with the first approach, and I can take answer equals to minimum of answer comma cost both into, I will purchase the minimum of the two elements, minimum of need 1 need 2, right? Let us say um, minimum of the need 1 need 2, because three elements, both of them require three elements, so I purchase minimum of the need 1 need 2 with the cost both, right? Right. And then rest what will be left? Rest maximum minus minimum will be left. So like in this case, maximum was 5, 5 minus 3, two elements will be left to purchase, and they will be purchased with the cost 2, right? They will be purchased with the cost 2. And when is that the case? When need 2 is greater than need 1, right? Cost 2. So basically, if need 2 is more, because after purchasing the minimum, only need 2 will be left, right? But if, let us say, if need 1 was more, then what will happen? Then answer will be updated in this way. Answer will be updated in this way. Is that correct? Cost 1, because now I have to purchase type 1 elements only. Type 1 elements only. So you understood this. I can use cost both for the minimum. But what if now cost both in this case was as low as, let us say, 4. As low as, let us say, 4. So I first complete the minimum requirement with the cost both. I first complete minimum requirement with cost both. So I get 3 type 1 plus 3 type 2. Now I have to purchase what? I have to purchase two of these as well. Two of these more, right? I have to purchase two more, two more type 2. Is that correct? Two more type 2. Is that correct? I hope that is correct. So since I have to purchase two more elements of type 2, then what will I do? Will I use a cost 2 which will cost me 5 for a type 2 element, or will I use a cost both which will cost me only 4 for a type 2 element? Because this will also give me one type 2 element, and this will also give me one type 2 element. So will I use 5 cost or will I use a 4 cost? I will definitely use this 4 cost. So the simple thing is that the remaining the remaining mx minus mn will be purchased with minimum of cost 2 comma cost both. That is very correct. Why? Because for the remaining I can use cost 2, because cost 2 will give me cost 2 will give me one type 2 element, and mx minus mn type 2 elements were left that can be purchased, and cost both will also give me one type 2 elements, and mx minus mn elements are remaining, so they can be purchased with the cost. So these both costs can be used, so I will definitely use the minimum of these two, right? because I want the answer to be, my final cost to be minimized. So I will use minimum of these two. And first, minimum of the two elements will obviously be purchased with cost both, will obviously be purchased with cost both, right? So simply you can do what? Simply you can do what? You can do the implementation now. So first of all, I use I use only cost one into need one plus cost two into need two. Simply purchasing one element of need one, need one elements of type one and need two elements of type two with cost one and cost two respectively. Then I calculate minimum and maximum of need one. If need two is more, then obviously so elements of type two will be left, and else type one will be left. If they are equal, you might be wondering what if they are equal. If they are equal, mx minus m1 will simply be 0, and we will purchase all the elements with cost both only, right? Now what will happen? I purchase the minimum of the two with the cost both, minimum of the two with the cost both if I need to, right? Or simply, you can also do it in one line. You can purchase the minimum of the two elements with cost both, or cost one plus cost two, or you can purchase them with cost one plus cost two as well, right? Minimum of the two elements. So now what will happen? And the rest will be left how much? Mx minus mn elements will be left. They can purchase with either cost two or cost both. And in this case, since type 1 is left, you can use either cost both or cost 1 to purchase the remaining type 1 elements. Is that clear? So you can finally return the minimum of all these three answers possible. So everyone who is listening to this question, is this approach clear? Is there any problem in this question right now? I hope there is no problem. If there is any, you can write it in the chat box. I will move on to the next question right now. Okay, so now what will happen? This question is smallest all ones multiple. So this is a really tricky question if you actually think about it. It's not that simple. So you are basically given an integer k. You have to find the smallest integer n that is divisible by k, that consists of only the digit 1 in its decimal representation. Example 1, 11, 111, 11111, so on, right? And then return an integer denoting the number of digits in the decimal representation of n. So like 1 has only one digit, 11 has only two digits, triple one has three digits. You have to return the number of digits. And if no such digit n will exist, return -1. So if, for example, you have k equals to 3, then 111 is divisible by 3. So the output will be 3, right? So yeah, that's the idea for the question. Um, okay, so this is not a simple question as I told you. You will have to think about this one. You will have to think about this one. So k equals to 3. Okay, so let us say I'm given k, right? So I'm given k and I want smallest integer n that is divisible by k. So simply if I tell you n is a multiple of k, that is true because n is divisible by k. N is a multiple of k. So I can write n equals to k into k1, k into, let us say, x, where x is an integer, right? N equals to k into x. And then what will happen? N is what? N is 1 plus, so so not 1 plus, n is 1 1 1 1, so on, some ones, right? Some ones. And whenever you are given something like some ones, some twos, what you can do is that you can write them as 1 plus 10 plus 11 plus 1, sorry, 10 plus 100 plus 1000 plus so on. If you see, 1 plus 10 is 11, 1 plus 10 plus 100 is 111. And so basically, this will simply give me what? This will give me all possible ends 1, 1, 1, 1, 1, 1, 1, 1, this sequence, right? And this is what? This is what? This sequence is a geometric progression. This is a GP with A equals to 1 and R equals to 10. If you do not know about GP, I request you to brush your math fundamentals. A GP is nothing but something of a type which starts with A, and then the next element is A star R, and the next element is A into R square, next element is A into R cube, and so on. This is a AP, GP, sorry, GP, and s- we n is a sum of a GP. And what is the sum of a GP? Sum is equals to A into R to the power n minus 1 divided by R minus 1. So this is the sum formula of a GP. So in this case, will be A equals to 1, R is 10, so 10 to the power, and how many numbers are here? So how many numbers do we actually want right here? So this is number of terms right here. So it is not n in this case. How many number of terms? So like n was 11, so I would have used two terms. If n was 111, I would have used three terms. So can you see that I am using the number of terms equal to the length of n, equal to the length of n, right? If I wanted one, only one term. If I wanted 11, only two terms. If I wanted 111, only three terms, which is equal to the length of n. Is that correct? I hope that is correct. So r to the power length of n minus 1 is what it is what it is. So 10 to the power len minus 1 divided by 10 minus 1. So it is nothing but sum sum is equals to what? Sum of the GP is equals to n, right? Sum is equals to n, so n is finally equals to 10 to the power len minus 1 and whole divided by 10 minus 1, which is 9. So 9 into n plus 1 is equals to 10 to the power len. If you just keep the keep the variables in the right place. So 9 into n plus 1 equals to 10 to the power length of n. So so 9 into uh, now the thing is that this is n, and what do I want? What do I want? N. Do I want n or n equals to k into x? I want n equals to k into x because I I am I know that n is a multiple of k, right? So what if I write k into x equals to 10 to the power len minus 1 and whole divided by 9. Now what will happen? Now what will happen? Let's use pen. So now what will happen? So this equation will become 9kx plus 1 equals to 10 to the power len. Is that right? Just after rearranging this equation. That is the major equation that we have. Now, x is an integer, as I told you in the beginning. This is an integer. Now, what will happen? 9kx equals to 9999, so on. Right? 9999, so on. Now what will happen? Are you with me on this question? Some of you might not be able to solve this third question because it's a tricky one. So x equals to 9, how many times? Len times, right? 9 len times divided by 9k. 9k, that is my x. And I I just want that x is an integer. So for x to be an integer, 9k must completely divide this number. 9k must completely divide this number. So, and what is this number? This number is repeating nines. So what do? I do 9k and 999, 999, so on. 999, so on. So what will happen? So whenever I get a remainder, so like let us say in this case, like let us say k equals to 7. Let us say k equals to what? K equals to 7. Now what will happen? I'm trying for this case. So 9k will be 63. 9k will be what? 63. 9k will be what? 63. So I have this 63 right here. I do 1. I do 63. What am I left with? I am left with 6, 3. I'm left with 36. I again bring a 9. Now I will see that. What? I will see that. Again, I will have to do something. Right. So 63 into, if I do 5, if I do 5, if I do 5, then I will get 315. Then again, I will do something and I will keep on doing this. I will keep on doing this until I get a remainder of 0. Until I get a remainder of 0. Until I get a remainder of 0. And the number of nines that I bring here during this process is the length of this 99999. And how many nines I use is the length of n. How many nines I will use is the length of n, right? Is that clear? Is that clear to all of you? So now what you will do? So I think uh, if you are aware about this division process, then you would have really understood this, right? So what do I do? Now the question is, what if we do not find such a number? So till when should we continue? So till when should we continue? That's a question. So now, like in this case, like k equals to let us say 2. So I will use 18 and I will use 9, 9 and so on. Right? Now I know that the answer here is -1. So it is not possible. It is not possible. Right? So I need to know that when should I stop? Because the remainder will never be 0. The remainder will never be 0. So this loop will be an infinite loop and it will never terminate. So I need to know the stopping point, right? So what will happen in this case? Like I do 18 into 5. So 18, so this will result in 9. Again a 99 comes. Again a 99 comes. Right? And this 9 was the remainder last time. After doing this operation again, I am left with again a remainder of 9. And if you notice, if I get the same remainder again, if I get the same remainder again, does that not mean that I will fall into the same loop once again? I will fall into the same loop once again. Again 99 will come, again 90 will be subtracted, again the remainder will be 9, and again 99 will come. So if so if 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 a remainder is repeated, if a remainder is repeated, अगर रिमाइंडर रिपीट होता है तो break the loop, because now the answer will never be possible. And if you think that how many distinct remainders are possible, so this number is 18. So I can have remainders only from 0 to 17. So I cannot have more than 18 distinct remainders. Is that clear? I cannot have, I can't have more than 18 remainders. And what is 18 meaning here? Or more than 9k remainders, right? So I cannot have more than 9k remainders. Then what will happen? So this simply means that this simply means that you cannot have more than 9k remainders, right? So so you just need to repeat the process only up to 9k times, not more than that, because after that it is just redundant. So this is what I did in this question. You just need to do the process how much times? 9k times. So first of all, since I am needing 9k, I will multiply k into 9. I go from 1 to 9k. I see if the remainder is 0, then that means I have to terminate the process and return, because now I have got the length of my n. I have got the length of my n, and this will be the length of my n. What is the length of n? The number of nines that I am using is also the length of n. So I simply return I, because I is the number of nines that have been used. And then obviously you will do the remainder. Now what I have done in this case, what I have done in the loop, like 99. So this remainder will be what? 99 modulo 18, right? So I have just done num equals to num modulo k. That will be done. And how to bring another 9? Now this, so for this you need to see, like the remainder was 9 and you transfer another 9. So how are they basically added? How are they basically added? They are added as rem remainder into 10 plus 9, right? Remainder into 10 plus 9. So num into 10 plus 9. Initially the remainder will be 0, and uh, it will become 9, right? Initially it will be 0. First 9 we bring, the number will become 9, then number will become 9, then we bring another 9. So what are we doing? Just remainder into 10 plus 9 to get the new dividend, and whenever we get a 0, we return the length. And if we do not get it in all these key operations, that means the process will never end. So simply return -1. Simply return -1. So I hope this question is clear to all of you. If it's clear, please tell me. If this is clear, please tell me fast. Okay, so now um, I hope this will be clear to all of you. Now let us try the last question, question number 4, which is a really difficult question of the day. Okay, so you are given two integers low and high. An integer is called balanced if it satisfies the both of the following conditions. It contains at least two digits, and the sum at even positions is equal to the sum at odd positions. So the sum at even positions must be equal to the sum at odd positions. It contains at least two digits. Return an integer representing the number of balanced integers in the range low to high. Now, first of all, if you read this line, you must have thought that this is the property of multiples of 11. So why do I not use all the multiples in the range low to high and print the answer? But it will be a problematic thing in this case. Why? Because the remainder of n are not just limited to such numbers. Like this number is also divisible by 11, divisible by 11. But if you think carefully, the sum at even positions here is 11, but at odd positions here is 0. So that is not going to work, right? So guys, question 4 has started. Be with me because this is not an easy question. So you would have to be with me for the whole time during this question, right? So you cannot use multiple multiples of 11. So why did I explain this? Because this line simply leads the children to think about think about multiples of 11, right? So why is that wrong? I've told you. And now what is the condition? It should be balanced. If it satisfies the following condition, it will have to have at least two digits. Now if you think, if it has only one digit, if it has only one digit, then obviously the sum at odd positions will be, so like if it has only one digit, one, sum at odd positions will be 1 and sum at even position will be 0. So it can never be equals to, it can never be the same, right? It can never be the same if it has only one digit. If only one digit, sum at odd can be never be what? Sum at even, unless the number is zero itself, right? If the number is zero itself. So if you think about zero, so we do not have to take zero. We just want it between low and high, and low will be 1 to 115. 1 to 115. Now, what can you think of? You want to find balanced integers. Let us say x. If I have a function x, f of if I have a function solve up to x, then if I want to find just low to high, what can I do? What can I do? I can say solve up to high minus solve up to low minus 1, right? This will give me all the balanced integers in the range low to high. If I make such a function, right? Since this is a low to high, so this will contain from 1 to high, this will contain to 1 to low minus 1, and so this is basically what? This is 1 to low minus 1 and low to high. So these and these will cancel, right? So this is what I am supposed to do. This is what I am supposed to do. So now my main goal is what? My main goal is to find this find this nasty function. So simply, if you first of all think about if x is equals to 0, simply return 0 because there is no integer from 1 to, sorry, from 1 to 0, right? There is no integer from 1 to 0, right? If we are asked solve up to 0, so you can simply return 0 if x equals to 0, right? And then after that, how what will you do? After that, uh, if I tell you, I told you that already the one digit numbers can never be balanced. One digit numbers can never be balanced. Now we will think about how to generate the numbers that are balanced, and they should be up to what? Up to my only up to n. So we are making a long function solve up to n, right? Up to n. So first of all, I will do what? I will store I will store digits of n in a vector of integer digits. I will store this, right? So because I know I need the digits, right? I know I need the digits. I know I need the digits. So like I have n equals to, let us say this number. I have n equals to, let us say 129. This means digits equals to 1 comma 2 comma 9, right? Digits equals to 1 comma 2 comma 9. Now what will happen? Um, so I get the digits. How will I get them? I can simply take 129 modulo 10. It will be 9. I will push it into digits. Then I will divide it by 10. I will get 12. Again, I push 12 modulo 10, which is 2 into the digits. So the digits will look like initially after those modulo 10 and divide by 10 operations, the digits will be 9 to 1. And then I reverse it. And finally, the digits will be 1 to 9, right? So what I've done, I store I store a v which is equals to n. So this is a temporary, so that my n in the question does not change. I just store it in a v. I make a vector of integer digits, and I do while v greater than 0, I will push v percent 10, and when I push v percent 10, I divide v by 10. So like it was 1 to 9. I push 9, I push 9, I push 9, 1 to 9, I push 9 and divide by 10. I push 2, divide by 10. I push 1, I divide by 10. And finally, v equals to 0. So the loop terminates. Now I reverse the digits so that I can. So earlier I had 9, comma 2, comma 1 in the array. After reversing, it becomes 1, comma 2, comma 9. Right? Right here, n equals to 129. So this will give me the digits of the array. Now length equals to digits dot size. I obviously need the length, right? I obviously need the length. And now we will talk about the solution that we are thinking about. So this is not a simple question. This is a very hard DP problem. Digit DP is used and it has 5 states. So if you are not thoroughly aware with the concept of dynamic programming, I need you to revise it. I need you to learn it first and then come to this question. This is not for beginners. Okay, so let's try this question. So first of all, if I think about this, first of all, I will think of making a DP function. Let us say I am at an index IDX. I am at an index IDX because all the numbers from 1 to high, 1 to n will have some digits less than equals to length of digits of n. right? The length of digits of n से तो कम ही होंगे ना. So like if it was 129, then I will have three spaces, and in these three spaces I can make a one digit number. One digit number would have been like 002. I could have made a two digit number. A two digit number could have been like 220, and right here 0. So I can make a one digit number, I can make a two digit number, I can make a three digit number, but I know that I have to be less than or equals to n. And how am I going to ensure that? How am I going to ensure that I always stay less than equal to n? So like if I know that I have made the first digit of the current number as 1, the second digit, if the number up to here is equals to my n, let us say, so I can use only 0 or only 1 or 2 at this place. If I use 3 at this place, so if I have a current number and it is equal to, I'm at an index idx, let us say I'm at this position. So if the previous positions are all equal, if the previous positions are all equal, if previous positions are all equal to n, this means that I cannot have a number greater than 2 at this position. Like if I make 130, that is invalid because it should be less than n, but is not. So if previous positions are all equals to n, like in this case, the previous positions for this was only 1. So the all the previous positions are equal to n. So we have a tight bound that we can have only 0 or 1 or 2 right here. So we can have, so like 130 is valid, but 10, 11, and 12 are valid. And now that we know about this, we also have to store, is it a tight bound? Is it a tight bound? This is, so what do I mean by tight bound? This boolean, are all the previous positions equals to n. So like if if I if I use 0 here, so all the previous positions are not equals to n. So now tight will be equals to false after this. New tight. Let us say n tight is new tight will be false. 1 1, again now the now it should be 1 2, but it is 1 1, so it has changed. So new tight is false. So now it is not a tight bound. And if I again use 1 2, then the new tight is equals to true. Then the new tight is equals to true because still it is a tight bound. Now what if all the previous number were not equal to the n? If previous positions are not equal to n, what does this mean? They will be less than n, obviously, because we are generating a correct number which will be less than or equals to n. And now if the previous positions are not equal to n, they cannot be equals to n, so they will be obviously less than n. So like in this case, what happens is that 129 was the number. Let us say at idx equals to 0, I used 0. So current number is equals to 0 and two spaces are left, 0. So all the previous positions are not equals to that of the n. So obviously my number is currently less than n, and it can never exceed n now. So I can use I can use any digit 0 to 9 now. Is that clear? Even if I use 9 here, in the worst case, if I use 9 here, still the maximum number is what? 99. This maximum number can be 99, which will be a valid number. The number will always be valid now. Now, I also need one more state. I also need one more state. I have to start the number. Remember, I told you that the number cannot be zero. I told you here because the number cannot be zero. I am having only from 1 to n. I have to start the number. So one thing is started. One boolean is started. Why started? Started means started means started means the number is not zero. Because if I use all the zeros, then that will be a invalid number. Like in this case, zero is an invalid number, as I told you. Zero is an invalid number because I am having in solve up to x, I am having all the balanced digits from 1 to x. Although 0 is balanced, but it does not lie in the range 1 to x. So I have to maintain a boolean started. Started means the number is not 0. And if the started is false, the current number is all the zeros, right? The current number is all the zeros. And the next state that I am having is the state which is parity. Parity. So what is parity? Whether this is an odd index or an even index. This is the fourth state of my DP. This is the fourth state of my DP. Correct? So what will happen in this case? Uh, Whether this is an odd index or an even index. So if it is an odd index, it will contribute to the sum of odd. And if it is an even index, it will contribute to the sum of even positioned digits. And I want both these sums to be equal. So I want of sum at odd positions equals to sum at even positions. So instead of maintaining two sums, now this is the very crucial part of this question. Whenever you are uh, given to minimize two sums, whether it is a graph problem, whether it is any kind of a problem, you do not store two different sums. You never store two different sums in such a case. You never store two different sums in such a case, even if there was some plus constant here, plus some constant here, like plus one. Even if there was plus one, you do not store two different sums in such a case. You store you store sum at odd positions minus sum at even positions. You store sum at odd positions minus sum at even positions, and let us say indifference equals to sum at odd minus sum at even positions. So finally, I want difference is equals to 0. Finally, I want a difference equals to 0. That is the final requirement that I want, right? So, this is the final state difference. Now, what do I do? Whenever, whenever, whenever parity is odd, whenever the parity is odd, I do difference plus equals to the digit that I use, right? Because odd is added, and whenever parity is even, what do? I do difference minus equals to digit, right? Minus equal to digit that I use at IDX, that I use at IDX, right? That I use at idx. Now this will give me the difference up to here. This will give me the difference up to here. And if that final difference, and when to terminate, when to terminate, if idx equals to length, this means I have reached my final index. And now what will happen? Now what will happen? If difference is equals to 0 and started, because remember, if it has not started, what will happen? If it has not started, the difference will still be 0. Difference will still be 0, right? Because there there was no odd, there was no even, right? Initially the difference will be 0, right? Initially the difference will be 0. And if it has not started, the difference is equals to 0. So I want the number to have started and the difference to be 0 finally. If these both conditions hold, then I return 1 because this is a valid number. Else I return I return 0 because this is not a valid number, right? So this is the base case. This is the base case when I reach the len idx equals to len. If the difference is 0 and the number started, then you return 1 because this is a valid number. Otherwise, this is not a valid number, right? And then what will you do? So basically, you had five states. You had five states, and if I tell the number of the DP array that you have to use, first of all, IDX. Now you are given n is less than equals to 10 to the power 15. So there are less than 16 digits. So use DP of, for a safe bound, you use 20 for the first state. Where is my wait? Where is my function? Let me write the function for you. Um, yeah, this is the function. This is the function. This is the function. This is my function, right? This is my function. First state was IDX. IDX can go up to a max of, since n equals to 10 15 at 10 to the power 15 at max. So 15 or 16 digits. So for a safe bound 20. Tight. Tight means what? Is it equal to n till now or is it less than n till now? So only two states. This is a boolean. Has it, so next state is started. Has it started till now or has it not started till now? Only two states. Next is parity. Is the index odd or is the index even? So only two states again. Now difference. Difference means what? Difference means what? Difference means, so you can also eliminate this parity state because parity is simply idx percent 2 also in some cases. In this case, it is not uh, because idx depends on the position where we started, right? Idx parity depends on the position where it started as well. But you can eliminate the parity if you want, right? So this would so it would reduce the DP states by two only. And finally, the difference. So now, for difference, how many should you have? Now, what for this you would have to imagine what could be the minimum difference and what could be the maximum difference. So, like for the minimum difference, like you know, I have at max 16 length. So, eight odd positions and eight even positions. So, at max, the difference can be 8 into 9 because all the odd positions are 9 and all the even positions are 0, let us say. Then the difference will be 8 into 9 equals to 72. Else, min difference is what else? Min difference will be what? 8 into minus 9 because all the even positions can be 9 and all the odd positions can be 0. So this will be result in again minus 72. So difference will lie from minus 72 to plus 72. Now, what will happen? Are you able to index the negative positions? No, obviously not. You cannot index the negative positions, right? You cannot. index the negative positions. So, so what will happen? Um, so what will happen? You will have to add something. So you will have to have difference plus, let us say 150, so as to ensure, that difference plus, or not 150, you can have difference plus 73, 73 also, so that the minimum, the minimum will also be positive, so that you can index minus 72 to plus 72 all. So how many states will it have? It will have 72 plus 73, which is almost 150 states. So almost 150 states. So we will not store difference, but we will store, we will store difference plus 73 all the times. That's the idea, right? We will store difference plus 73 all the times. So I will say that I've said that offset equals to 73, and I am using difference plus offset every time. So that is the idea for the question. My end, I am resolving that. Right, can you see my screen? Can you see my screen right now? Did you understand the difference plus 73 thing or not?